Hey, John, what if we had nuclear-powered rockets?
That's a crazy thought. Let's see what would happen. Imagine rockets so powerful they could reach Mars in just a few weeks. No massive fuel tanks, no long waiting, just pure nuclear energy pushing forward. This isn't science fiction. Scientists have dreamt of nuclear-powered rockets for decades. Instead of burning fuel, these rockets use atomic reactions to release extreme heat. That heat turns hydrogen gas into plasma, blasting it through the rocket's nozzle. The result? A small amount of fuel creates enormous thrust, almost limitless efficiency. Ordinary rockets burn chemical fuel, but nuclear engines could be hundreds of times stronger. They could shorten space travel, reduce costs, and even make deep space missions possible. But nuclear power in space isn't just about speed, it's also about risk. So, what if we actually built one? Let's launch into this nuclear future. A nuclear rocket carries a small reactor instead of traditional fuel tanks. Inside, uranium atoms split apart, releasing incredible heat known as nuclear fission. This heat supercharges liquid hydrogen, shooting it out the back as plasma exhaust. The more heat, the faster the particles move, and the stronger the thrust. With this system, rockets could reach Mars in 45 days instead of 9 months. They could even reach the outer planets without waiting for perfect orbital alignments. Scientists call these engines NTPS, nuclear thermal propulsion systems. NASA and DARPA are already testing small prototypes that might fly within this decade. Nuclear propulsion isn't just theory, it's the next big leap after chemical engines. But every leap comes with danger, and this one glows radioactive. A nuclear rocket could carry astronauts to Mars safely and bring them back faster. Less travel time means fewer supplies, less radiation exposure, and lower mission risks. It could open the door to permanent space colonies and interplanetary trade routes. Imagine sending rescue missions to distant worlds without waiting years for alignment. Nuclear rockets could power entire space stations, running lights, air, and artificial gravity. They could even mine asteroids for resources using the same onboard reactor power. Earth's orbit could fill with nuclear cargo ships, moving supplies between planets daily. Space tourism could expand, orbital hotels, moon bases, even Mars resorts powered by reactors. Nuclear propulsion could make humanity a truly spacefaring species, fast, fearless, unstoppable. But before we celebrate, there's a dark side glowing behind that atomic flame. Nuclear engines use radioactive materials, dangerous if something goes wrong during launch. A single failed takeoff could scatter uranium or plutonium across the Earth's atmosphere. That's why engineers design heavy shielding to contain radiation during every flight. But heavy protection means extra weight, which reduces speed and fuel efficiency drastically. Launch accidents, rocket explosions, or re-entry failures could trigger radioactive disasters globally. Even a safe launch must manage leftover radiation near astronauts aboard the rocket. If shielding fails, radiation could damage tissues, DNA, or onboard electronics mid-flight. Disposal of used fuel rods in orbit could also threaten satellites and debris systems. Some scientists fear a space Chernobyl if nuclear tests go wrong outside Earth. But with modern materials and AI controls, humanity might finally handle that risk wisely. With nuclear rockets, deep space becomes our new backyard, from Mars to Saturn's moons. Missions to Neptune or Pluto could take months instead of decades of drifting silently. Nuclear-powered cargo ships could build supply chains between planets like interstellar highways. Space telescopes powered by small reactors could explore beyond the solar system entirely. Even interstellar probes, reaching nearby stars, might finally be possible with atomic energy. But we must handle power with wisdom. One mistake could poison space for centuries. If balanced carefully, nuclear propulsion could save humanity when Earth becomes uninhabitable. It's risky, yes, but progress has always demanded courage and responsible innovation. The stars are closer than ever. We just need the will to reach them. Subscribe now for more What If worlds, where imagination fuels the engines of tomorrow.